project was originally developed by myself, Michael Ogbinar, and my teammate, Michael Ignacio, under the guidance of Dr. Pros Naval, as part of the requirements for our Intro to AI course in UP Diliman College of Engineering Artificial Intelligence program. For this PyCon PH 2023 presentation, I will walk you through the relation extraction from online Philippine news source presentation. Here, we are proposing a methodology to extract pairwise entity relationships from an online Philippine news source. The application retrieves information regarding public personalities and then uses classical machine learning method to predict a pairwise relationship between two entities. This is the outline for this presentation. Essentially, we are given 60 minutes and the topics are divided into 6. So introduction, the framework of techniques and approaches, the methodology, the analysis of results, the conclusion and future studies, recommendations for future studies, and ultimately the question and answer portion. Okay, before we begin, I would like to start with an introduction about myself. I have always been a developer at heart, but unfortunately never had a developer career. So you can think of me as a frustrated programmer. My first language was Turbo Pascal back when I was trying to learn. I was interested with the idea of programming computers. This was self-taught, after which I took on C and C++, JavaScript, and Java back in my undergrad years. My early career landed me in IT. Essentially, it was platforms and infrastructure in corporate. So we handled IT operations, fixed system issues. I mostly applied my programming skills in automating tasks, such as using Bash, Perl, and, well, of course, Python. Eventually, I ended up in data, working in the data space, and have been through many different roles and projects as well as industries. I work primarily in data management, data governance, as well as analytics and data science. So feel free to link up with me via LinkedIn, so you can just add me, search me there. For those who are interested to try the project, this project that we did, you can see the link of my GitHub repository. So just visit there and download the code. And you can also call me Mike, by the way. Next, I'd like to quickly talk about my affiliations. So I'm currently with San Miguel Corporation. So I head the data and analytics group of San Miguel. We look at the overall maturity in terms of data management, governance practices, as well as its applications in analytics, data science, and operations research. Alongside that, I teach Python and machine learning on the side with FTW, or the For the Women Foundation. So we help women who would like to career shift into data science. I also act as advisors for data science capstone projects. Currently, or more recently, I joined the AI program in UP Diliman, so this is where we got the opportunity to do this project. In terms of communities, I actively engage with AAP, or the Analytics Association of the Philippines, and of course my alma mater, De La Salle. So they recently launched the Dr. Andrew L. Tan Data Science Institute. So they are going to start launching data science, analytics, data management, no, visualization, programs, no, as part of the uh, curriculums, no, in De La Salle. And then lastly, although I have been a Python user for a long time and occasionally an R user, it's only been recently that I've been active in the different programming communities. No? So special shout out to Python Philippines as well as RUG. No? As you go through your career, no, as developers, programmers, regardless if it's just for hobby or for work, it's always good to give back to your community. So in my case, this is my attempt. So I hope you guys like it and appreciate it. Yeah, that's it for my introduction. We can go ahead with the actual presentation proper. So let's talk about the motivation, no, for this project. Uh, and you can see with these different types of, you know, news and content that is being springing out um, in the internet now. There's a lot of information uh, around us, and it's really, the challenge is becoming really to more on consumption. No? So the internet is a beautiful thing because it gives us access to so much data. No? The problem is that the most interesting data is mostly unstructured, no? And it would take a lot of manual effort and expertise in order to piece them together into something that's much easier to query or analyze, no? For whatever use case that you have. Our main motivation for this study is posing the question on how we might begin to address this challenge by focusing our eyes in the written text, no? Particularly as online news reports. A lot more insights and understanding would be generated from these different articles, no? If we could easily see connections and relations between them, no? Depending on whatever entities that we're trying to scrutinize, such as persons, events, things, locations, organizations, no? To name a few. And if you are able to piece them together, then it gives us a different perspective in the type of information that we are currently consuming. It allows us to see patterns and trends that we were not able to see before, with just looking at the current articles, unless of course you are an expert in that field. And so we generalize this problem into developing a method of processing unstructured data or semi-structured data into a structured format. More specifically, we want to take an unstructured set of text data. This text is further tokenized and tagged to add metadata information, such as if this entity is a person, is a location, etc. As an example, this information is then further drilled down or classified to identify relationships between these entities, whether within the scope of the sentence. These classifications are consolidated and connected into a knowledge database, which can carry the network connections for further analysis or querying. And there are a lot of network analysis techniques out there, particularly graph analysis and community analysis. So essentially, that's the motivation when we started this. Okay, so let's start constructing how are we going to actually do that, because just thinking about it, it kind of feels complex. So we want to first construct a framework of our approach, and this will consist with different key techniques that we're going to utilize. And the first one is going to act as our foundation. So it's essentially NLP, natural language processing, because we're heavily going to be working with text data. So NLP is primarily used no, is a set of tasks and techniques that are central to text processing, text analysis, and manipulation. Ultimately, this is the help that we need, no, in order to make text more understandable or workable for computing tasks, such as what we're going to do today, machine learning. In NLP, there are different groups of tasks, and this can be divided into roughly 4 categories. No? Tasks that are related to syntax, tasks that are related to semantics, and then tasks that are related to discourse, and then speech. For the techniques that will be important for us, it's going to be primarily in semantics, since we are looking at connections. No? And the first one is called name entity recognition, or NER. And then the next one is relationship extraction, or RE. Named entity recognition allows us to identify, classify entities by person, place, event, and similar meta taggings. No? It can be pronoun, identifying if it's a pronoun or a noun or a verb, or any sort of part of speech. No? But primarily for our purposes, we just want them to be able to tag if it's a person, place, event, etc. Well, in this case, it's a person. The second one is relation extraction. This allows us to classify what is the relationship between the two entities that we identify. No? So for example, if it's entity A, entity B, how they are related. For example, are they part of a whole? So let's say they are part of a family, as an example, or they have a specific instance, no? That's more detailed. Like for example, this entity 1 is a son of entity 2. So it's more of a classification problem also. Okay. Next, the core of our approach is the learning component. No? We expand it beyond the NLP tasks. At the top, we are using or we are going to use a supervised learning approach, which simply means that the model learns by example. Along with our input variable, no, you can see here, we also give our model the corresponding correct labels, in this case here. No? While training, the model gets to look at which label corresponds to our data, and hence find patterns, no, between our data and those labels. The type of supervised learning that we will be building is called a classification model. The model is defined as the process of recognition, understanding, and grouping of objects and ideas into a preset categories, aka some sort of, let's like a subpopulation. With the help of these pre-categorized training datasets, classification in machine learning programs leverage a wide range of algorithms to classify future datasets into respective and relevant categories. Classification algorithms used in machine learning utilize input training data. Again, this one. For the purpose of predicting likelihood or probability that the data follows will fall into one of the predetermined categories. One of the most common applications of classification is filtering emails into spam or not spam. No, and you can as everyone would know, since by now everyone here would be, you would have email, no? And spam is a common occurrence. No? Similarly, no, this graphic that we have, the classifier is trying to classify the different shapes based on the labels, no, whether they are rectangle, circle, triangle, or hexagon. No? The way that we validate how a trained classifier performs is that we use a test data set. No? So this test data set, they also have the same features that we pass on to the classifier, and it tries to predict them. And then since it's a test data set, we know what their actual labels are, then we can validate if they were properly able to classify, no? The unseen data. So One key problem of supervised models is the need for access to training data, no? Which is here, this one. Unfortunately, training data or labeled data is costly because it requires an expert to manually tag information, no? So if the labeled data set does not already exist, then we need to gather them, and then we need to validate and label them properly. This poses us a problem for our project since our project comes from public sources, and most probably are not labeled. No, this means that if we want to label them manually, we need to spend some time to either label them ourselves if the domain is easy to understand, or if it's a bit if it requires a level of expertise, then there might be additional cost, no, besides the time of the developers. And because of this, we might need to come up with an approach to address this, no? And that's the part where the novelty comes in for our project. So what we will be using to address this problem is called a distantly supervised learning approach. So it's still a supervised approach. The difference is that it's a type of learning scheme in which a classifier is learned given a weakly labeled training set. So why is it weakly? The reason being is that essentially we're going to take a data set that is entirely unrelated to the data set that we're trying to score, no, or classify. In this case, that data set that we're going to use is Wikipedia, because Wikipedia is, essentially you can think of Wikipedia as a database, and there are a lot of information there that is considered by many to be at a certain level truthful. No? Why? Because there is heuristics embedded in Wikipedia through the process of crowdsourcing, right? So people are the ones that are submitting information, and another set of people are validating that information. So there's a certain level of accuracy or certain level of expertise already embedded, no, within Wikipedia. So that's what we're going to use. Again, the reason it's called weakly labeled is that it's probably not related to the dataset that we're trying to score on, which means there might be a large number of data that may be unrelated, no, or essentially it adds noise to the training. That's essentially the weakness, no, of a distantly supervised learning approach. Given this, it is crucial that we evaluate resulting models, no, and aim for at least a 60% accuracy as beginning of a workable classification model. No, just to a quick step back now. When you're doing models or you're training models, you always need to look at how much the level of accuracy, resulting level of accuracy, is found, no, from during your evaluation. If the accuracy is too high, there might be a certain level of um, overfitting that's happening, meaning it's going to be hard to work with unseen data. But if it's too low, in this case, below 60%, the model might probably be just as random as a flipping of a coin. No? So we want to be at least 60% in such a way that we are a bit better than just random prediction. Okay. The last piece of the puzzle that we need to be able to address is that since we are working with text data, um, we need to think of a way to be able to normalize or as well as represent text information in a consistent manner. Okay. Ultimately, there's the question of how do machines understand text, and the short answer is that they don't. Okay. Instead, we enable this by converting text into a different format or data structure. That is what machines are used to performing analysis, no? Such as machine learning. And this form is in the form of numbers or vectors. Okay. The tool that we will need to use in order to enable this is called an encoder. An encoder, it takes your text and creates what is called embeddings. So the embeddings would be essentially the vector or numbers that represent the text. No? This will allow us to create like a vector space of representations that will allow us to make the text information that we're processing to be comparable with each other. No? And that will allow us, since it's converted already to a set of vectors, then it's more workable. It allows us to work with this data and to process them with machine learning. Okay. So ultimately, the expected project outcomes would show something like this, right? So there is the article, and from the article, we want to be able to tag specific entities within a specific sentence. And then with that sentence, we're going to identify or predict the relationship of those two entities. Okay, so that's the expected output of this project. Now that we have gathered the key techniques that we will be using in this project against our expected outcome, we will now outline them, put them all together into a methodology. The methodology consists of two major steps: the training and testing of our champion model using a distantly supervised approach, and the application of the trained model into our news article, or essentially the scoring of the text data. Quickly, let me read you through the steps. The first one is the training and testing. So it's composed of 7 steps. The first one is we use our Wikipedia dataset. So it's called the Wiki 80. And we process that into two entities with the person 1 and then person 2 and then the target relation structure or format. We apply these entities into the Spacey Universal Sentence Encoder. So this is our encoder that will transform our entities from text into feature embeddings. And then the resulting dataset, we will split into the test and train data, the test and train splits, which we will use a 90-to-10 split ratio. We will then use the scikit-learn library, which is a set of machine learning models or algorithms for use of our model training. We will not be applying or changing the parameters, the hyperparameters of the models. Essentially, we will just use what is default and standard. And then the last step is that we will evaluate the models using the F1 metric. So the F1 metric is similar to accuracy, and that will be the basis to identify our champion model. Once we are through this, we will go through the application or scoring step. There are 6 steps. The first one is that we will create a web scraper. The web scraper will connect with the inquirer.net website to extract articles. And this is done using Beautiful Soup and Request Library. The collected tests will be processed using NLTK or the Natural Language Toolkit together with pandas. Sentence tokens will be tagged by wikifire.org API. So the wikifire.org.api will allow us to do name entity recognition. And this will be filtered to only sentences with person-to-person structure. The resulting named entities are converted to encodings using the Spacey Universal Sentence Encoder. And the process samples are classified by our champion model. So this one is the key step that we are trying to get to. And then after which we are going to do some analysis of what are the resulting relations that was classified, and we are going to manually evaluate them by checking directly with Wikipedia, since Wikipedia is our technically our expert. When we were developing this project, we were only given 1.5 months to complete it. So from designing, ideation, until development and results. So we opted to use Python to leverage the thriving ecosystem of data and machine learning libraries that is already widely used, because we needed to, get up and running as fast as we can. Okay, and Python really helped out a lot in that. Um, so for data collection and preparation, it consisted of being able to send requests to an HTTP website, web scraping, and handling of HTML documents. We used request library and beautiful soup respectively for this. Once the data has been downloaded, we use primarily NLTK, or the Natural Language Toolkit, together with pandas for text manipulation and data transformation. For the modeling components of the project, we use pandas and scikit-learn, as well as the SPACY Universal Sentence Encoder by Google. Lastly, we use NetworkX for graph network construction and visualization. Specifically for the models used within scikit-learn, we use the following. The first one, here, you can see here, the first one is we use, for the linear models, we used SUD classifier and logistic regression. And then the next one would be support vector machines. Then next is the k-nearest neighbor classifier, the decision tree classifier, and the naive Bayes, or the multinomial naive Bayes model classifier. For the ensembles, we use the random forest classifier, the extra-tease classifier, the add-boost classifier, the histogram-based gradient boosting classifier, and then the gradient-based, the gradient boosting classifier. For the new, we also tried some basic, very basic neural network for MLP classifier, and then some minor pre-processing tools for min-max scaling. And then finally, for our metrics, we experimented with a number of things, but ultimately we just settled on F1 because we needed to be able to properly compare all of the different models. No? So F1 score. We also did some, we also added the time library because we wanted to do some measurements. No? So there are some timing specifics, no, to give you guys an idea of how much time it took from just extraction of the data, processing, encoding, training. No? For our data collection step, we first analyze the inquirer website and identify which information we want to capture. So you can see here, right? In this case, we wanted to capture the nation or news related only to the Philippines and only in English. So this will help minimize the noise that we will be able to capture and only focus on more consistent data. In their website, they have a page dedicated to nation article links, and we go ahead and scrape that. So in order to do this, we create a function, you can see here, that accepts a page count. The page is then downloaded using a request post call, and the resulting HTML is then processed using beautiful soup to only retrieve information that we need, which is the set or the list of article links, which you can see here. Once we have the links to our articles, we need to extract them and get some pertinent details. Again, we construct a function to do this. As you can see here. Once more, we use beautiful soup and request a post call combination. Once we have downloaded the HTML code, we inspect the tags that contain information that might be useful later on, and write code that will parse them out and assign them into a dictionary. We had to do a lot of tests, no? For this step, because the articles did have consistent HTML structure, and it was causing a lot of errors and oftentimes ran into runtime exceptions during our tests. Eventually, we arrive at a stable code and are done with this step. So you can see here the step, and we were able to find, information about the URL, the title, the author, some pertinent details, as well as the date stamp of the article and the actual um, article body of text, which we call sentences. The next step is through the use of the Wikifire web service. So the name entity recognition step is enabled by this. So this service was created along the same mindset as our project. They aimed at using Wikipedia information to facilitate entity tagging as a means to do named entity recognition based on the data that can be found on Wikipedia. Since we only set out to create a relation extraction model, we use this step for our name entity recognition to minimize the complexity of our project. There are two steps to accomplish our NER step. The first is the creation of our tokenization function, which is here. This essentially goes over the article main body of text and cleanses it and generates a token set of sentences. We do this by using a sentence tokenizer that identifies sentences within a series of paragraphs and breaks them down into an array or a list of sentences. Okay. These sentences are then iteratively passed into an annotation function, which is you can see here. This function essentially calls an API to Wikifire using the request service alongside a set of parameters that we configured as part of our setup to identify the information that we will need. There's actually a lot of information Wikifire provides, but we only focus on a certain set that is relevant for our study. The great thing about Wikifire service is that it returns a lot of information beyond just the label, such as the title of the label, the Wikipedia article related to the title, the wiki ID, its page rank, and character location in the sentence. So we capture this information as well, since it might be useful for future setups. But ultimately, you can already start imagining that the articles, the URL articles, we can connect directly to the relevant Wikipedia links. And that starts to, you can already imagine how we can connect all of this together into a seamless, more or less, network of information. Finally, we create a function called generate data. You can see here that integrates all of the previous functions mentioned into a clean data extraction pipeline. We accept a start and end number of pages in the Encoder website. We will begin scraping of links. The final result set is the consolidated information of links, sentence tokens, and identified labels and annotated information. Note that for this study, we only limited capture to person and to entity sentence tokens. This code can easily be configured to capture different types of entities, such as identified by our NER step, as well as more than 2 entities. So for now, we just wanted to limit our project again. But in the future, if you want to be able to expand this study, you can definitely use other types of entities like location, organization, events, etc., as well as including more than just 2 entities in the sentence. For our model training preparation step, we take the Wiki80 dataset and split them into our train and test sets. We pass them through our universal encoder and return with 512 new features generated. So you can see here that this is not anymore texts. So before, these were words, etc., but it's now converted into a vector representation of the text using our universal encoder. And since we have encoded our text into vector embeddings, our data is now compatible with our machine learning models. And, we use Pickle to save this information. Just because, Pickle. And finally, for our training step, we create two functions. So there are two functions that you can see here. The first is the train model, which is essentially a helper model which accepts a model instance parameter. This instance is then trained with our training dataset, and we evaluated using our test dataset, which you can see here. Upon evaluation, we call another function called getMetrics. This is essentially a helper function also to run and capture metrics for evaluation of our model. So you can see here an example of how we instantiated the models, as well as assigning the different data types. The data types are the test, the train, as well as the predicted test values for metrics evaluation. And we capture all of that into a list, and then we iterate into a simple comprehension loop, which will capture all of the results. The last step in our journey is the actual scoring or application of our trained model against the captured news articles. From our training of the Wiki80 dataset, we found that the support vector machines, or the SVM, performed the best, and so we use that to predict against our tag person-to-person entity sentence tokens. Okay, so the tokens were saved in this document, so processed data frame, and then we transformed them and then converted them to a list, in which this list was passed into our champion model, and we run the predict, and then we essentially combined everything into a data frame to form our report, which you can see here below. These are the names, the tokens, and then the prediction. Okay, so before we go ahead and review or look at the resulting statistics, let's just do a quick review of the methodology that we use, as well as the configuration. So again, it's divided into 2 or 3 major steps. The first one is the training. So the Wiki80 dataset is essentially 56,000 samples of labeled relations. The labels is actually 80 classes. That's why it's called Wiki80. We take the dataset and run it through the universal encoder after it's been processed, which will generate the features, the 512 features. Then we split it 90 to 10. The training set is 50,400 samples, and the test is 5,600 samples. We do this because we only have a small data set for training. And then we do the training, and then we pass it on to the testing. So the 5,600 is essentially goes through the same process, and then we use that to predict. We use the trained models to predict against this testing, and then we measure the accuracy, in this case using the F1 metric. The winning or the champion model that we call is then passed on to the final step, which is the application or the scoring of the different sentence tokens from the articles. So we scrape the Inquirer net news articles that are specific to the Philippines. The total number of scraped articles is around 900. We tokenize this and tag them using our Wikifire online service. And then we filter them to only the sentences that are person to person, which is around 246 samples. And again, we convert them using the universal sentence encoder, and then we score them. We predict the classifications and store the information. Okay, so essentially that's the methodology configuration. And now we move on to the results. Okay, so as shown in table 1, the initial knowledge extraction phase took almost 6 hours. So 900 pages 246 sentences, 6 hours total. So this takes a lot of time. Out of the total 246 sentences tagged by Wikifire with 2-person entities, we use our champion model, no, to predict the relation classification of each. Now, just a quick recap. So if you recall, we trained this model using the Wiki80, and here is an example of what it looks like. The Wiki80 is around, again, 56,000 and with around 80 classes now. So that's around 630 samples per class and 70 per class for both train and test. And this is the shape of the Wiki80 data. This is what it looks like, just to give you guys a flavor of the training data set. So the Wiki80 consists of 80 relationships, and upon classification, we were able to predict at around 27 class predictions. For the classes applicable to person-to-person relationships, we have identified the following classes, 7 classes now. So child, father, followed by follows mother, sibling, and spouse. So those are the person-to-person relationships now that we expect to see. In table number 2, which is here, yeah, I already covered that now. So that train test of the 90-10 at around 56,000 samples. The last table, table number 3, walks us through on the machine learning algorithms that was used, as we have a total of 12 models that had training approximate time of around, a total of 50 minutes across every one. So every time we had to rerun this, it's 15 minutes. So it took us a long time. We used F1 score as our primary model evaluation method to compare each classifier, so you can see it here, and identify the champion model. So you can see here, sometimes the models take not a lot of time, like for this. Then some are very fast, but the performance is really low. Some are really took a long time, but again, not really performing. So ultimately, the default hyperparameters was used, for every one of this, but we chose support vector machines, which scored at 60.73 accuracy. Table 4, this one, summarizes the results of our of using the SVM classifier model, where the top 5 classes, predicted were father, spouse, director, head of government, mother. For comparison purposes, we also manually validated the results using Wikipedia. So since there's not really a lot of instances, so to 246, we checked with Wikipedia, and the results are summarized here in table number 5. Overall, out of the 246 samples, 99 were found to be valid, while the 143 that were not found to be valid resulted to a 67.35% accuracy. Out of the 99 valid samples, 97 were predictions of father class, while 2 were for spouse. The rest of the person-person classes yielded invalid predictions. So you can see here that some of the things that we kind of predicted at the very start, there's a lot of noise, and for some reason our model is a bit biased towards a father classification. To add an additional layer of analysis to our results, we review specific instances of valid, not valid, and near misses. So let's go through each. For the valid list, it looks like our model was able to easily identify father and spouse classifications. So there are actually a lot of instances of father and spouse, was actually more specifically father, that the model was able to properly classify. So you can see here Ferdinand and Bongbong Marcos, and then we have Ramon Bong Revilla, and then we have Sara and Rodrigo Duterte. For the spouse, we have Benigno Aquino and Corazon Aquino. For the not valid list, it looks like there were instances of non-person relation classification that occurred, but also you can see that again our model has a certain bias towards predicting father as a relationship. No? But particularly, we also focus on this, where occupation, head of government, competition, class, and movement was classified incorrectly. And lastly, we wish to highlight the near misses, no, that were almost correct. During our review of the results, you can see here, we found near misses such as token with entities Ungsan and Ungsan Suki, which was classified as mother, where in real life, Ungsan is actually the father of Ungsan Suki. The token, Kim Atienza and Lito Atienza entity pair, on the other hand, has a son-father relationship, but was tagged as spouse. Sorry. Um, Moving on, we found the Ferdinand Marcos and Martin Romualdez entity pair, which was incorrectly tagged as father, but it's actually cousins in real life. No, so but one particular reason here is that our training data did not have a cousin class. No, so then we have Pia Cayetano and Alan Peter Cayetano. The predicted relationship is actually a position, and the correct classification should have been sibling. So we have a sibling class, but it was not used. No? The last one is another is Gian Soto, Tito Soto, head of government, and it should have been nephew or uncle, but there is no uncle or nephew class. And then we have Joseph Estrada, Loy Ejercito, where we have position held, but it should have been spouse. As an extra step for this project, we went ahead and created a graph out of the resulting entities and relations. Using network library, in a visual manner, we can easily see the relations in the form of edges and against the entity nodes within the network layout. No? For future studies, no? For those who would like to extend this, this can further be improved by applying visual cues for relationships or groups of relationships of interest. No? Using graph analytics, you can surface more interesting connections and using the use of community detection, so network analytics. So just to highlight, we have Bong Revilla, Ramon Revilla, we have Edgardo Angara and Sonny Angara, we have Martin Romualdez and his cousin Ferdinand Marcos, we have Lito Atienza, Kim Atienza here, Andel Ampatuan Sr., I think it's somewhere here. Here, Andal Ampatuan Jr., and then we have Alberto Gonzalez, Paul Gonzalez, to highlight just a few. Okay? And now for the conclusion and recommendations for future studies. Given the complexity of the problem, we aimed for an 80% minimum accuracy, just to prove that this methodology works. And we were able to achieve 60.73%, which is, I would say, not bad. It's not perfect, it's not great, but it's not bad. And this is mostly due to the noise and limitations of the training data, right? Specifically because we used the distant supervision approach. Nevertheless, the completion of this study gives us an indication that there is, and I have to say this, that there is really potential in using distantly supervised learning methodology, right? In lieu of costly labeled training data, as the resulting classifications of the news article result to actually 67.65% after we manually validated them using Wikipedia. Now, if anyone would like to, expand this further, we categorize our recommendations into two. The first one is on research. So this is essentially focused more on the concept no? Or the domain, and some recommendations include expanding to other languages or dialects, um, trying out different online text sources. Maybe you can try out blogs, maybe, or uh, books. Additionally, you can also go beyond person-to-person relations. No? You can try person to um, locations, person or location to person, person to organizations, no? um, or events, things like that. So there's a lot of things you can try out. Additionally, you can also expand it to more than 2 entities. No? And lastly, you can try to look for people that are actually trying to apply classification or relation extraction problems in specific domains, no? And it would be great to partner with them. On the technical side of our recommendations, we recommend to try out more models. So far, we only tried 12 models from the scikit-learn library. There are definitely a lot of implementations of classification models. Additionally, we did not really optimize and focus on generation of features, as well as the optimization of the hyperparameter. So there's a lot of opportunities here. That is really quick win, from a technical point of view. And of course, the last one would be to add more data. So if you recall, the Wiki 80 only has 80 relations and only 56,000 samples. That Wikipedia definitely would have more than that, but it will take time and processing to set up that kind of data set, right? It's not impossible, but it will take a bit of time. And yeah, that's essentially it. And yeah, this ends my talk about using Python to create an application that extracts articles and generates a graph knowledge base of related person-to-person entities from online Philippine news sources. We believe, no, that there is a lot of potential ways to expand this and apply this to different types of problems, such as community detection, fraud detection, anomaly detection, and similar use cases. And with this, we are now opening the floor for questions. Thank you very much for listening.
So Ben has a question. He is asking, how was your experience in cleaning the articles data set?
Okay. Can you hear me, Nia?
Yeah.
Yes, okay. So with respect to cleaning or cleansing of the data, that's actually usually the most difficult when you're dealing with text data. And actually we kind of cheated that because what we did is that the whole project uses minimal cleansing, because what we actually did is we just focus on cutting the paragraphs or the articles into sentence tokens, and then we focus on just identifying the named entities. So once we have the named entities, we kind of don't really care anymore of about the other words now. And the methodology for identifying that it's already within part of the Wikifire API. So it's kind of how we approach. It's very minimal when it comes to the cleansing.
Wikifire is the one that's doing the work here. So okay. I hope that answers your question, Ben. So yeah, the next question up is from John, and he says, how did you set up the hyperparameters of some classifier model? Have you used hyperparameter tuning? Oh, yeah.
Yes. For this project, what we did was we didn't really focus on producing the best model. We focused more on identifying which model between the different types of algorithms. So in this case, we identified 12 models or algorithms to use, but we did not focus on the hyperparameter. That's actually one of our recommendations, that in the future who would like to people who would like to try this project out and expand it, you can try and looking at tuning the parameters to see if it will improve the predictability of the model.
Okay, so 12 models and then tuning it. Okay, so yeah, I hope that answers your question, John. And the next question we have is from Aaron. And he says he's an outsider when it comes to data analysis and machine learning. But is the reason for near misses and misses is the lack of clear distinction what output is expected? Okay. For instance,
Yes, that's correct. So one of our recommendations also for expansion of this project is really looking at feature engineering. So when you talk about feature engineering, it's giving the model what features will help separate, make distinct the different classification. In this case, what we only did was we just focus on the different names. So what it does is when it tries to learn using the Wiki80 data is that historically, if it was able to learn a relationship that is very near the two names, then it will tries its best to provide a classification. Now, with some of the names that we were introduced that it predicted differently, it's highly probable that there was some distinction that was found, but it's not near to the relationship that it initially expected, because it's again the problem with the distantly supervised learning methodology is that we're learning from a different data set versus the data set that should have been labeled properly before. Now, in this case, ideally we would learn from a data set that's all about person-to-person relationships. But since we don't have that, what we did was we took from a different data set, which might have introduced noise information or information that might have misled our models. So that's primarily the reason. So it's kind of like when you're trying to learn for another project, but your experience is coming from a different life experience, so to speak. So you try to decide on that new information using that, which is not familiar with the context or the right context.
Oh yeah, that's in depth. So next question we have is from Nico. And were you able to identify the direction, in which an entity's relationship points to? Example, entity A is the father of entity B.
Oh, that's a good question. Ideally, yes. That's part of the project. Now we want to be able to find the directionability of the relationship. But we did not focus on that for this project. Now, although you can see some of the prediction are, we found some that were actually correct, like this person is actually the father of this person, but it's not something that we measured, no? So probably it's also an expansion that we can do, because for me it during that time we were actually hard pressed for time and we did not want to add additional complexity. Having a one directional classification would actually be better, no? But that's actually an additional type of data set that we would need.